disruptive technology that will revolutionize breast cancer surgery. Breast cancer is a major societal issue. Every year, there are more than 2 million cases of breast cancer, and 1 in every 8 women will develop breast cancer during their lives. Treatment requires surgery, and there are two main options. Mastectomy, which is used in around 40% of the cases, is a drastic intervention corresponding to a complete amputation of the breast. Breast-conserving surgery is the preferred treatment and is used in around 60% of the cases. Here, only the tumor is removed, leaving the rest of the breast intact. However, this procedure requires an invasive pre-operative localization, and in 30% of the cases, the surgeon fails to fully remove the tumor, requiring a second surgery to treat the patient. To illustrate the problems in breast cancer treatment, let's follow patient journey after diagnosis. The first step is to acquire breast medical imaging data using MRI. Here, the patient is laying with the belly down and the breast extended due to gravity, a very different position than during surgery. Then, a team of clinicians decides the treatment plan using these images. There are two problems with this. First, the patient's position in the imaging data is different than in surgery, affecting the clinician's perception of the tumor localization. Second, these images are two-dimensional, limiting the clinician's ability to visualize the 3D anatomical structure of both the breast and the tumor. This may lead to avoidable mastectomies being prescribed with increased costs and worse patient outcomes. In the case of breast-conserving surgery, the next step is to perform the preoperative tumor localization. The most common method is the insertion of a metallic wire inside the breast until the tumor. This is an invasive and highly uncomfortable procedure, since the wire has to stay inside the patient for a few days, sometimes a week. In the operating room, surgeons use the metallic wire to localize the tumor and extract it. However, they have no information about the size and shape of the tumor. This leads to some cancer tissue not being removed in about 30% of the cases, requiring a second surgery. The main difficulties with the current approach are caused by the changes in the patient's position and the limited visualization tools during surgery. Ideally, we would like surgeons to be able to see the tumor inside the patient's breast before they make even the first incision. And that's exactly what our technology, BreastXR, enables. Our component are advanced AI algorithms that perform medical imaging analysis and predict breast tissue deformation caused by changes in position. These algorithms use real-time data acquired by an intelligent 3D sensing system that performs an automatic surface scan in the operating room, so that we can align the tumor position with the patient's breast in real time. Finally, the tumor with other relevant anatomical features are displayed to the surgeons using an extended reality headset running our optimized interface. This allows the surgeon to see the tumor through the patient's skin. So let's see how BreastXR improves the patient journey. After MRI, our AI algorithms process the medical imaging data, segment it, and simulate how the breast deforms with changes in position. This allows us to build high-fidelity, patient-specific 3D breast models so that clinicians can make more informed decisions, leading to fewer mastectomies and better surgery planning in general. BreastXR eliminates the need for the preoperative localization. No wires inside the patient, fewer patient visits, and saving a procedure that costs almost $400. During surgery, BreastXR augments the surgeon's vision, allowing them to see the tumor through the patient's skin, leading to more accurate surgeries and, very importantly, reducing the number of re-excisions. There's no doubt that BreastXR is disruptive, but how big is its market? Just in the US and EU, there are over 800,000 breast cancer patients every year, corresponding to more than 500,000 tumor localizations. To estimate the economic value of BreastXR, we start by considering the technology that we replace, the wire-guided localization with an average price of $375. However, BreastXR brings much more value. The value due to reduced re-excisions is $600, and due to avoided mastectomies is $2,000. This gives a total value of over $3,000 for each BreastXR localization. Currently, tumor localization is a service provided by hospitals to patients. Our customers are therefore hospitals and cancer clinics. We'll use a software-as-a-service business model. We install the equipment and provide maintenance for free and charge for each individual surgery. We'll adopt a tiered pricing strategy depending on the volume of surgeries. Our average price of $1,100 per localization is larger than conventional methods, but is considerably smaller than its economic value, saving downstream costs of almost $2,000 per procedure. Still, with this point, we estimate an operating margin of more than 80% and a market of $0.6 billion. Moreover, our technology will generate an additional $1 billion in savings that will be shared between hospitals, patients, and insurance, greatly facilitating adoption. And this is not far into the future. We started working in this project in 2014, And in 2020, we showed the proof of concept with TRL3. This year, we reached TRL4, started collecting a unique imaging data set, and will file our first IP application. Next year, we'll have a beta product to start the first in-human feasibility study in 2025 and achieve TRL6. We'll start the product and manufacturing design to have a final product by 2025. In the same year, we'll start a large international clinical, multi-center clinical trial to obtain certification in the EU and US by late 2026, so that we can go to market in 2027. To fund our project, we have already secured non-diluted public funding of $1.5 million that will last to 2025. We need an additional $14 million to take our product to market. This project requires an extensive expertise in a wide range of topics. Our team is led by myself with experience in computer vision and machine learning, João Santinha, an expert in medical imaging and AI, and Pedro Gouveia, a breast cancer surgeon and pioneer medical XR researcher. In addition, we have a large and growing team of brilliant scientists, software developers, surgeons, mechanical engineers, and more to tackle the unique challenges of this project. We are confident that we have the right team to bring our technology to market. So in summary, BreastXR will substantially improve breast cancer treatment for all stakeholders. For patients, it will give better surgical outcomes and quality of life. For clinicians, it will increase productivity and provide better tools. And for hospitals, it will save costs and improve clinical workflows. Feel free to contact us at hekavisionxr@gmail.com, and thank you for your attention.